It's a pleasure to be here. My name is Julia Stoyanovich. I'm an assistant professor of computer science and engineering at the Tandon School of Engineering at NYU. And I'm also an assistant professor of data science at the Center for Data Science at NYU. And my third line of affiliation here is that I direct the recently established Center for Responsible AI at NYU. And today it will be my pleasure to tell you a little bit about the course or courses that I have been developing and teaching at the Center for Data Science, specifically that are on responsible data science. And I want to stress already at the beginning, and I also put some links into the Etherpad page, that all course materials are publicly available. Everything is on GitHub. So please use whatever you like. And I'd be more than happy to also work with you to help incorporate these materials into your courses. So please be in touch. So what is responsible data science specifically, and why did I think that courses would be needed in this area? The goal here is to teach future data scientists to develop tools and to think critically about the impacts of these tools on society. And although numerous ethics courses are available, with many focusing specifically on technology and computer ethics, pedagogical approaches used in these courses rely exclusively on texts rather than on software development or on data analysis. Technical students often consider these courses unimportant. And I say this because I was once also a computer science student, and so I am very easily able to put myself in the shoes of these students. And they find them a distraction from the real material, so to say. And so to develop instructional materials and methodologies that are thoughtful and engaging, I think that we must strive for balance. And this is what I'm depicting here. And that is balance between texts and coding, between critique and solution, and between cutting edge research and practical applicability. Finding such balance is particularly difficult in the young field of responsible data science, or RDS, where we're only now starting to understand how to interface between the intrinsically different methodologies of engineering and social sciences. So let me just start, because I have very limited time today, with a quick overview of the courses that I'm mentioning here. I've been teaching responsible data science at NYU for 3 years, always in the spring semester. And the first offering in spring 2019 was a special topics course where I had 18 master's and PhD students in the data science and computer science programs, and 3 people auditing. In 2020, we already had 46 students with 4 people auditing. And just this year, 2021, the course was also rolled out to the undergraduate students at NYU. It's a requirement of our new bachelor's degree, undergraduate bachelor's degree in data science. And so I co-taught this course with a colleague, George Wood, concurrently for undergrads and for graduate students. We had 60 students in each of these, so 120, and there were very long waiting lists before enrollment. So there's quite a bit of interest in this material, and the course is seeing substantial growth. The audience, as I mentioned, are undergraduate and graduate students in technical disciplines, data science and computer science primarily. The only prerequisite is introduction to data science or computer science. Machine learning is not a prerequisite for this course, and this is deliberate. This is because I really want to make sure that we catch students before they go too deeply down the machine learning and AI path. And the challenge here primarily, again, is to reconcile technical training with interdisciplinary ethical concerns. I co-taught the course with George Wood, who is a sociologist, this past year. His research focuses on inequalities in public health and criminal justice, and he brought that perspective to the course. Also, in this spring's offering, we were able to start learning how to scale beyond NYU. Here I'm showing a photo and a quote from Debbie Euster, who taught a version of this course at Ramapo College in New Jersey. And she basically went to every lecture by Zoom that I offered, and then she would present this material 1 week later in her class. And as she states here, there's an urgent need for ready-to-adopt curricular materials in data science ethics. And this is why she wanted to participate in this project. We also recently published, together with the wonderful Armando Lewis, who is an education researcher and who took my course the first time that it was offered. We recently published a paper in the International Journal of AI Education, where you can see a bit more about the course and also learn about the educational methodology. So on to the course structure. This is a real technical course. We have lectures once a week, and we have hands-on labs also once a week. And of course, this past spring, we taught it in blended mode, meaning that most students were remote, although some were on campus. So NYU had in-person instruction. And so we had to deal with those challenges. And ultimately, across the two courses, undergrad and grad, we had 2 lectures scheduled and 4 labs. Again, just to reinforce that this is a technical course, we had several homeworks, we had a team project, there was a final exam, there were programming labs that students would hand in after the lab. And the course project had as its deliverable, a kind of a nutritional label for an automated decision system of the student's choice. And I'm happy to speak about that later during the discussion. Essentially, a nutritional label is a kind of an audit of an automated decision system that the students chose. Once again, all course materials are in the open source. That means that all the lab notebooks, all the slides, and all the reading are on the course website. And we use Python, various open source libraries, and Google Colab. Here I want to show, to illustrate with the help of a picture, that this course, although it's very strongly technical, is able to draw a very engaged and a very diverse group of students. And in my many years of teaching in the higher ed setting, I have to say that, and I've always taught computer science courses, that this was the most demographically diverse course that I had the pleasure of teaching. The course has 4 modules. The first is Algorithmic Fairness. And here I'm giving you just a taste of what the course webpage looks like. Please go ahead and explore it yourself. We have a reader that accompanies every course module. There isn't a textbook yet, although I'm hoping to make some progress towards that starting this summer. And then also Google Colab notebooks are posted here for the labs for a particular week. In the first module, one of the topics we cover is bias in predictive analytics, the interpretation of that term. Do we mean statistical bias or societal? And then we speak about bias in the data, using the metaphor that data is a mirror reflection of the world. And when we think about bias, we interrogate this reflection. I'm not going to have time to go into the details here, but this is just to give you the flavor of some of the presentation materials that I developed and that the course uses. The second module speaks about the data science lifecycle and the responsibility concerns, ethics, legal compliance, privacy, data protection, data quality that permeate the data science lifecycle. So here again, the module overview, there is a reader that we compiled, George and I. And here we return again to a conversation on bias in computer systems. Here I'm showing the 3 types of bias that are due to Batya Friedman and Helen Nissenbaum from their 1996 paper, depicted as a dragon here with 3 heads, 1 head for each type of bias. And we focus on technical and emergent bias in this module specifically, reinforcing that to fight bias, you have to state your beliefs and assumptions explicitly. You cannot simply rely speaks about 3 types of equity that, again, I don't have time to discuss here, but this is just to give you the flavor of the positioning. We speak about the importance of looking at the data lifecycle when addressing responsibility concerns. We speak about the importance of making clear what assumptions and what models you are using and whether they are appropriate for the task at hand. The third module focuses on data protection and privacy specifically, and here we speak about differential privacy using randomized response as kind of the entry point to this topic. We discuss several recent papers. We talk about privacy preserving synthetic data generation. We do exercises using an open source toolkit that my students and I developed called the Data Synthesizer. And we also discuss legal frameworks that focus on data protection, but also more generally on transparency and accountability of automated decision making. And some of this narrative, specifically about legal frameworks and regulatory mechanisms, is based on the experience and the work that I do in technology regulation in New York City and also more broadly. The fourth module and final module is transparency and interpretability. Here we speak about several topics. One of these is auditing black box models, explaining their decisions, understanding why particular decisions are made that impact individuals or population groups. We speak about public disclosure, and here I use this metaphor of a nutritional label that I already mentioned when discussing the course project. In summary, because I'm out of time, I want to say that my interpretation of responsible data science, and this is the course that I teach, is that it incorporates ethics and legal compliance, but also personal responsibility, and also technical, very technical topics like data quality. In this technical course, we draw content from fairness, accountability, and transparency, from data engineering, and from security and privacy. We learn algorithmic techniques for data analysis, and we also learn about recent legal and regulatory frameworks. And the main point that I reinforce throughout the course is that the problems that we encounter here are not purely technical. They are socio-technical, and so technology alone cannot solve these problems. That all being said, my perspective is still that of a pragmatic engineer, not of a technology skeptic. And so I'm never going to say that we should not be using technology, we should not be using data science, rather that we should be careful about how we use it and for what purpose, and how we check whether in fact it works and what impacts it has on society. The last thing I'll say is that there is a comic book series that I have been developing with the brilliant Fala Arif Khan. Images that you saw today are also due to Fala. And this is an ongoing project that we have. We have so far released 2 comics in this series, and I use them as supplementary reading for the course. These are sort of at the level of survey papers for a technical audience, so please check them out. The first one is called Mirror Mirror. It's available in English, Spanish, and French so far, and we're looking to translate into other languages. And the last thing I'll mention is that I'm also in collaboration with the Queen's Public Library and P2PU, Peer-to-Peer University, that we've developed a public education course called We Are AI that is currently being piloted at the Queen's Public Library in New York City. And it also comes with a comic book series. These are much shorter and generally accessible, so please check them out. And thank you very much.
Thank you so much, Julia. That's a large body of work and I think really helpful as a resource for others. I mean, really, congratulations on all of the things that have been going on. Are there any questions for her about this or about how you might get access?
Yeah, so I guess I have a quick question for, you showed us a slide of someone that tried to like adopt your course as part of this project by taking your course and then teaching it a week later. I'm having tried to adopt other people's course material and then teach it. I'm curious how that went for her and whether she found it was like she was able to do it or there was things that she struggled with. Cause like, this is super exciting. Like this was a great looking course and I would love to be able to either take some chunks of it or take all of it and do it at my or college as well, because I think it covers a lot of things that I'd really like to share with my students. But I also want to make sure I can be successful with it, right?
Right. Great question. And thank you for asking that question because, part of the reason that I'm excited to be speaking to this audience today is because I do want people to take the course and to adopt it. So it wasn't just that Debbie came to class. She also came to every TA meeting. We worked very closely together, she and I, to make sure that the material is appropriate for her students. So this was, of course, the first exercise of this sort, right? She took extensive notes. And over the summer, she and I are going to sit down together to actually come up with a kind of a guideline for folks wanting to adopt these materials. But none of this is going to be automatic. I don't expect it to be the case that you can just take the stuff and run with it. And this is part of the problem with tech ethics, right? Is that there are very few people who feel at ease with both technology and ethics. And I have to overcome my imposter syndrome every day when I go out and teach utilitarianism and all of these topics that I was never trained on either. So it's very difficult material. I hope that over the 3 iterations so far that it underwent, that it's kind of more and more canned and accessible. It made a big difference to standardize the labs. So these labs run on Colab, so they're essentially out of the box. It limits the kinds of modules we can use also to teach, because not all software runs on Colab, not all libraries do, but we have this sort of canned set of modules. The most difficult thing is coming up with assignments, because we can't repeat exams, for example, right? So for those of you who decide to adopt portions of this course, I'd love to work with you to help come up with more resources, just questions and answers to these questions. But otherwise, I believe firmly, and Debbie can confirm, that it went well for her. She had 18 students. They appreciated the course, and it takes work, but it can be done.
Sure. And I have, Renan, I have more questions, but if other people have questions, I will not keep asking questions.
Yeah. Does anyone have a question for Julia too? Real quick. I think we have a question, one more.
I have a quick one. Where can we get a list of all the comics that you listed?
So
at the end of the session?
I put this all into Etherpad, it's called, right? But I can also paste into chat. I'll paste into chat. Yeah.
Thank you.
Yeah.
Of course, my pleasure.
And if
the
anyone
comics are brilliant, take a look. I can say it because I'm not the sole author, and the brilliance is due to Fala, my co-author. They're just really funny, so check them out.
I can tell, very innovative.
Yeah,
thanks.
Very innovative. We will do that too. If anyone has any other questions, we also can put them in the Etherpad. So as you're thinking about them, if you have another question for Julia, put it in the Etherpad. And Julia, if you're willing to look in there, and if you see questions.
Yeah, I'm there.
So I guess I have another question I hope that might be interesting for people to hear about, because I went to a workshop earlier this year where there was actually an ethicist presenting as part of the computer science workshop at a computer science conference. And so my question, you sort of mentioned this challenge with possible imposter syndrome. Did you actually work with having an ethicist or a philosopher, someone with a PhD in philosophy or something, come in and help you with making sure that you're constructing all that content correctly and sharing it? It sounded like you didn't have one in the classroom teaching with it, but there's still certainly components that they're experts on. And I'm kind of curious to see whether you worked with them or whether you just sort of tried to learn it yourself and come up with it.
So in the initial iterations, I learned myself, and still for the most part, it's essentially just, take the Oxford, or I think it's a Cambridge ontology of moral philosophy and go through that, right? So that's on my desk. I learned from sociologists more than I learned from philosophers. So I got a lot from Matt Salganik's book, Bit by Bit. And my initial kind of round of teaching consequentialism versus deontology, for example, is almost verbatim from that book. This time around, I co-taught, as I mentioned, with George Wood. He has a PhD in sociology from Oxford, and he has been exposed also to philosophy concepts. This past year, I have been working, though, very closely with a political philosopher who is the academic granddaughter of Rawls, John Rawls, who is very influential in this field, specifically in fairness in machine learning. And so the second volume of the technical comic book series that we used, and that I also used in the course, is based on this paper that we wrote together. Her name is Eleni Manis. So Eleni Manis, Fala, and I wrote a paper called Fairness and Friends, in which we map political philosophy concepts to their interpretations in fair machine learning, and we contest some of these mappings, etc. So this is difficult work, right? But we have started down that path.
Awesome.
Very nice. Very nice.
Thank you.